Good morning, students. I am Professor Priya Sharma of EC Department, SIRT College, Bhopal. Sage Anandam. So, this is our lecture 13 of the lecture series Digital Circuit System subject, which we are going through nowadays. The lecture 13 will cover the sampling theorems. So, basically, what is a sampling? Sampling of signals is the fundamental operation in signal processing. A continuous time signal is first converted to discrete time signal by sampling process. The samples of the signals must be taken depends on the maximum signal frequency present in the signal. Sampling theorem gives the complete idea about the sampling of the signals. Different types of samples are also taken like ideal sample, natural sample, and flat top samples. So what is sampling theorem? The statement of sampling theorem can be uh, understood by two points. First is a band limited signal of finite energy has no frequency component higher than the FM. FM is the maximum frequency of the signal is completely described by its by its sample values at uniform intervals less than or equal to 1 upon twice of maximum frequency of the signal second of paths. Our second point covers a band limited signal of finite energy which has no frequency components higher than FM hertz is completely recovered from the knowledge of its samples taken at the rate of twice of FM samples per second. This is the basic processing of a sampler. A continuous time signal is passed through a sampling device and we get the samples of the input signal like this. So what is the sampling criteria? Sampling theorem gives the criteria for the minimum number of samples that should be taken so that the recovery of the original signal will be there without any distortions. The sampling criteria is that the sampling frequency fs must be greater than or equal to twice of the maximum frequency of the signal of which samples we are taking. Nyquist rate is defined as the minimum sampling rate for the perfect reconstruction of the continuous time signal from the samples. While providing sampling theorem, if it does not follow the criteria and follows the sampling frequency is less than twice of the maximum frequency of the signal, then an error may occur that is known as aliasing. As you can see in this, the waveforms are overlapping at the ends or the edges. So at this point, the distortions will occur and the data is lost and it cannot be recovered. So there are three types of sampling: ideal sampling, natural sampling, and flat top sampling. Coming to the ideal sampling, like in time domain, these waveforms are in time domain and these waveforms are in the frequency domain. So first of all, talking about the time domain, sampling results in the conversion of continuous time signal into discrete time signals, and in frequency domain, sampling results in multiple translations of the signal spectrum, linear combination of shifted signal spectrum at integer multiples of sampling frequency. So in ideal sampling, it is simply denoted by these arrows. Samples are denoted by arrows. Firstly, a signal is passed through a sampler, and in the sampler we also provide an impulse of trains. Then this impulse of trains take the form of this original signal, and hence the samples are created. Then the natural sampling, the difference between the ideal sampling and natural sampling is this: as in the ideal sampling, a train of pulses cannot be generated having the infinite amplitude and zero width. So we use a train of pulses here. A train of pulses are passed as in the sampler, and the sampling frequency of this should be greater than or equal to twice of the maximum frequency of this continuous time signal, and hence natural samples are being created like this. You can see that the tops of these signals follow the continuous signal. So the train pulses will follow the signal in at the edges of the signal. So in natural sampling, each sample is pulse of train T with amplitude varying in accordance to signal value. Natural sampling may be thought of multiplication of signal with the train of pulses. Now coming to the flat top sampling, the disadvantage of a natural sampling is that following the signal, the amplitudes may disturb. So in flat top sampling, ideal pulses can't be generated. Earlier, the ideal impulse can't be generated. Practical sampling pulse will exist for a duration. In flat top sampling, for each sample, the value is hold for a duration t. Flat top sampling may be thought as output of a system with impulse response ht shown in the figure to input of the ideal samples. The continuous time signal is passed through an ideal ideal sampling, and ideal samples are produced. This is passed through a impulse response system having a train of pulses. Then we get the flat tops at the edges of the signal. This is how a flat top sample is created. First it will sample, and then it will hold till this position. Then it will again sample and hold for further train of pulse. This is how we do the sampling. I hope the sampling theorem is now clear. It is very simple. In case of any query, you can contact me. All the best, students. Work very hard. Thank you. Sejanandam.